All right, we're just past the top of the hour. Let's kick things off. Thank you to everyone who has joined so far. My name is Sarah Critchef. I am VP of Marketing at Edge Delta, and really excited to start this webinar, which is titled Chaos to Control, Telemetry Pipelines for all your observability and security data. Featuring our panelists, Ozan Unlu, CEO and founder of Edge Delta, and Nolan Chen, partner solutions architect at AWS. So we'll hand things over to Nolan to kick it off. And just actually one point of housekeeping. During the webinar, if you have any questions, please feel free to put them into the Q&A section at the bottom of your screen on the Zoom screen. If you're in full screen mode, you might not be able to see that button, so you might need to shrink your screen to see that. And you can put questions during the webinar, and we'll also have a Q&A section at the end. So we'll make sure we address everyone's questions either during the webinar or at the end. So I'll hand it over to you now, Nolan.
Thank you, Sarah. Can you see my screen okay?
Yep.
All right. So again, my name is Nolan. I'm a partner solutions architect at AWS. Now, before we dive into Edge Delta, I'd like to first spend a few minutes talking about one of our original core services, and that is, of course, S3 or Simple Storage Service, and how Edge Delta can help make your storage utilization on S3 more efficient, and in turn, make the applications that query S3 return better results. Now, the world has changed a lot since S3 was first introduced back in 2006. Back then, S3 was mostly used to upload human-generated content, such as PDFs, spreadsheets, and static images. Today, though, S3 stores data that's generated by both humans and machines. And a big difference today is that modern apps are generating hundreds of gigabytes, if not terabytes of data daily. Now, S3, because of its scalability, durability, and cost, has been a popular destination for storing both documents as well as telemetry logs, IoT sensor data, and so forth. Now, because of the central roles it plays, S3 is sometimes synonymous with data lakes on S3, where you can store both these unstructured and structured data from a wide range of sources. Now, the data source we're going to highlight today, though, is data from telemetry pipelines. Now, where is exactly all this telemetry and other data actually coming from when you're in AWS? Well, they're coming from different services that run on AWS, and we will list some of these services here, such as DynamoDB, Redshift, and SageMaker. Now, on top of these services are applications that can be sending a pipeline of telemetry data. Now, before we continue, let's also now talk about the costs of storing all of this data on S3. Now, one of S3's main appeal is its relatively low storage costs. As you see here, S3 standard starts at just over 2 cents per gigabyte per month. But in a world where the amount of telemetry data keeps increasing exponentially, even those 2 cents per gigabyte can start to add up. That's why Amazon also offers different storage classes for S3. Now, the basic idea behind this is that the less frequently you access your data, the less you should have to pay to store it. So on one end back here, over here on the left, we have S3 standard. That's costs about 2 cents per gig. On the other end, we have S3 Glacier Deep Archive, which can cost less than 1/10 of a penny per gigabyte of storage. Now, this is for data that you're not likely to need, but for you still can't afford to just throw away. Now, in between these two tiers at both ends, we can also have S3IA, which stands for infrequently accessed storage, which when needed. So this is for data which you're not likely to access, but when you need it, you got to be able to access it very quickly. Now, these different tiers of storage are useful for storing different classes of data with different access patterns. But that's why we also offer intelligent tiering. Now, with intelligent tiering, S3 can automatically move data to lower cost of storage based on the access patterns. Now, that said, there's still going to be some data that actually never really needs to be stored in S3 at all. In fact, sometimes when you store too much data that you don't need, it could lead to higher costs, not just higher costs, but also reduced application performance. Wouldn't it be great, though, if you could somehow pre-process all your data and filter out that data that you don't need before you store it in S3? Take Amazon Athena, for instance. So Athena is an instance that allows you to query and analyze data that's directly stored on S3 using SQL. Athena can query and analyze data that comes from telemetry pipelines, as well as data warehouses, ERPs, and even other clouds. But remember, the quality of the results you get from your queries are only as good as the data underneath. If you happen to have a lot of noise or irrelevant data, it could, of course, hinder your query performance and reduce the quality of your responses. That's why it can be helpful if you could pre-process and make sure that only relevant data is stored in S3 or Athena or any other service that needs to query and analyze the data. So with that, I'm going to now turn it to Ozan to tell you more about how Edge Delta can perform this pre-processing to optimize your costs and performance on S3.
Thank you, Nolan. So I'm pretty excited for this. I know in my LinkedIn post earlier, I talked about, this is the last time we're going to be able to do this, maybe before AI takes over. Maybe that's a little bit too optimistic about the progress of AI, but
Well,
excited to kind of talk through this. And, I think Telemetry Pipelines has such a good foundational, direct benefit with customers using S3. So I'm really excited to kind of chat through these concepts today. So, Nolan, you even mentioned this where it used to be that humans were creating these documents like PDFs and pictures and whatever else they were putting in S3. And now, we're seeing this. By next year, there is this massive growth of enterprise data. And, we talk about this big shift from consumer to enterprise. And, a couple of decades ago when I started working at Microsoft, I think that was the original mission statement of Microsoft, right? Like a Windows PC on every desk in every house. But now what we're seeing is, by next year, it's projected to be about 30 billion devices that are creating and sending data. So far, far, far more than the original kind of, one device per human on Earth. And so we're seeing this explosion of data. The second thing that we're seeing is, there is a lot of talk of this concept of a pendulum. So, back in the 60s and 70s, we had these big mainframes. And then with personal computers and then even, cell phones and the iPhone, it got from very central to very distributed. And that's really when we saw a lot of the consumers starting to create that data. And then we're seeing the pendulum swing back now with IoT and various different distributed services and serverless functions and everything else, where there's a lot of data being created. And we're seeing that it's estimated that about 49, almost half the world's data is going to be stored in the cloud. So, we all know the benefits of the cloud. We know the trends of this data going to the cloud. But it's interesting to kind of look at that pendulum of the benefits of the cloud and the benefits of also distributed edge processing as well. Finally, the third thing, which is massive adoption within the enterprise by next year, 94% for AI and ML. Now, we all know that AI and LLMs is very, very different than maybe basic primitive ML that's been used for a long time. But that number to me was quite staggering to say that, 94% of enterprises by next year will have adopted AI and ML. So when we think about telemetry data sets that are prevalent in the enterprise, there's this acronym that's used typically within observability that's called MELT. So it's, metrics, events, logs, traces. It's ordered that way because I think MELT is a nice thing that rolls off the tongue. But realistically, at least to me, as an ex-developer, the way that I think about it is logs, events, metrics, and traces in order of kind of when they were out there, when they were being used, when they were, people were getting value out of it. And so, I think all of us on this call know what logs are. Really, it's a timestamp record that's something within your machine data that will show you something that's happening within your systems. Events, it could be Windows events, but realistically, events here are talking about much more high levels, significant things that are substantial happening within your environment. Metrics, again, these are time series metrics. If anyone's seen, a dashboard, whether it's on Datadog or Splunk or another environment, those dashboards that you see, typically those are time series metrics that you're showing, tracking some specific thing over time. And then traces. Traces are really whether it's a distributed trace or whether it's a service map. I really like to think about this as sort of, how are your various different parts of your service communicating with each other? We're going to look at these top two today. The top two are very, very, very good fit for AI and LLMs, and I'm going to kind of talk through why here. So I don't know if we can all remember the ChatGPT moment from November of 22. It wasn't that long ago, but it was released then. The models weren't that much different. I mean, I think we're all seeing the ChatGPT models come out, and I think we're seeing them improved. But realistically, back at the time, the big, big, big benefit to these models was the accessibility. Inference was now very feasible. It was very easy to use. It almost looked like a Google search where you can just type in, a question and try to get an answer. And that was really the big progress forward for ChatGPT. Again, it wasn't necessarily that the algorithms were just mind-blowingly better. It was that it was really accessible. If we look at the value of these LLMs for terabytes and petabytes, again, going back to the logs and events, we're looking at first, efficient data processing. Second, natural language understanding. Third, the scalability and adaptability. And I'm going to go into those in a second. But one jarring statistic, just to keep us all on the same page about how big is a terabyte actually. If a human sat down and read through a terabyte manually, it would take him over 1,500 years to manually read through that terabyte. So that gives us a context for how big really is a terabyte of data. I think there was this famous picture of Bill Gates sitting on, a stack of paper that was 40 feet high or something like that, holding a CD-ROM. And I think even back in the day, I think that was something like 700 megabytes or something like that. So, terabytes, we're talking about millions of times more data than was being created, 10 or 15 or 20 years ago. So going to the efficient data processing, why are LLMs so powerful here? Well, you can process relatively vastly amounts of unstructured data. So this means, you can feed these logs and events directly into these LLMs and get a lot of output or feedback or understanding of that data. The second thing is there's no requirement for predefined structures or queries. So this is very powerful when you don't have to think through, okay, what is my potential event or log message or critical warning or thing that happens tomorrow that might lead to an outage or that might lead to me having to run some part of my playbook. The ability for LLMs to be able to, on the fly, understand these various different events and data sets without having to pre-configure them is a huge benefit that we're going to be going into as well. Finally, the scalability and adaptability, which is, the real-time analysis across large data sets. I put a question mark there because we're going to go into that topic a little bit more. But realistically, again, you can feed an LLM a lot of data, again, compared to what a human can really go through. So what are the challenges of high volume and scale in AI? Well, first of all, tokens are relatively very, very, very expensive. So if we think about the unit cost of analyzing a gigabyte in something like Splunk or Datadog, again, LLMs can be even thousands of times more expensive than that. And I don't think anyone is sitting here saying, Datadog or Splunk is very cheap or inexpensive, even to start as a baseline. But, again, tokens are expensive. They are coming down in price. But again, you can't just feed terabytes and petabytes of tokens directly into an LLM and try to get any type of high value out of it. The second thing is training is relatively infeasible for most. The actual cost to train a brand new model from scratch is something like $10 million. So that's a lot different than fine-tuning a model. We're going to talk about AWS Bedrock a little bit later on today. And, AWS Bedrock has a really great set of a ton of different, whether it's open source models or AWS models, Claude, there's a lot of different things that you can use there. Again, you're probably not going to go compete with Claude on your own and train a brand new model from scratch. But the great thing is you can take some of these models and fine tune them. So I think, that's the thing with scale and AI. Training is infeasible. Fine tuning is a possibility. Third thing is your team is likely new to AI. So, we've all had, I think, in large organizations, a few data scientists or a few AI or ML experts here and there. But your whole team is now having to try to understand how to utilize AI and get value out of it. And the fourth part is the privacy, security, and scalability of using these models. So, I think if we look at AWS Bedrock, they do a really good job of making it really clear, hey, we're not going to use your data for training. And that is one thing that's really a benefit to using a system like AWS Bedrock and be able to use the models within there. And so really, if we look at the challenges of high volume and scale in AI, there are some challenges here. But also, there's some huge benefits, especially for using this within observability and security. So, this old cliche of we're seeing continued very large increase in data over time. We've all seen that chart. I think we've all seen the statistics that I think there's about 40 to 60% annual growth of data based on various sources and statistics. But, again, this is a cliche, right? There's a lot of data being created. Just for my own experience, about 10 years ago when I was in observability and security, the average customers only had megabytes and gigabytes. Maybe the average customer had 5 or 10 gigabytes of data they're creating a day. Now at Edge Delta, when we're working with customers, a lot of our customers have 5 or 10 petabytes of data they're creating a day. So we're talking about, again, millions of times more data than was being created before. We're seeing enterprises shift left. So, the old approach of centralize and analyze or store and explore, right? That worked when you only had, let's say, 5 gigabytes of data. Great. I'm going to go send that into some index. I'm going to be able to build my searches or queries or dashboards or alerts later on from that index. That was a very reasonable approach at relatively small volumes of data. But we are seeing enterprises that have lots of data start to shift left and be more proactive. How are they doing that? Well, they're using telemetry pipelines. And telemetry pipelines can really start to process and curate that data. And then you can use that in your downstream systems, whether you're using it in a observability or security platform, or you're using it to effectively feed into AI to give you those observability and security insights at scale. So, Werner Vogel's had this great talk at the last reInvent, and I'm excited for this next reInvent that's coming up here in a few weeks. But, he talked through this concept of there was these two different types of houses. You can almost think of it as a double bell curve. So they were looking at these two different types of houses. They were saying one group of houses is using 50% more energy than the other group of houses. And they couldn't understand why. They, effectively had the same type of insulation, same roofing, same doors, same insulation on the windows. So they were really trying to figure out, why is it that this group of houses is using a lot more energy with, heating and all that kind of stuff? What they realized was the big difference is just simply, where's the meter? Is the meter in the basement where it's out of sight, out of mind? Or is the meter on the first floor where when you come in and you put your bag down after work, you have a possibility of looking at that meter and saying, I am using a lot of energy this month. And so, the prerequisites to optimizing your data streams, the exact same concepts apply to your data. It's just your data, when it comes to logs, metrics, events, traces, is probably orders of magnitude more complex than one simple number about how much energy you've been using that month. So what are the prerequisites? Measurement, visibility, and capabilities. The first thing is measurement. So we talk about data sources, we talk about optimization summaries, and we talk about destinations or tiers. So data sources, this can be all different types of data sources. So, on the left, you could have things like, AWS Lambda. You could have EKS. You could have EC2 instances. You could have IoT devices. You could have third-party applications. Like, for instance, hey, I'm an Akamai customer, or I'm a Fastly customer, and I need my WAF logs, and I need them to be streamed to a cloud endpoint. So all these things can be data sources, and you have to measure how much data is coming from each different data source. Second thing is the optimization summary. So, just because some source is creating a terabyte of data, that does not mean that you need to actually replicate that terabyte of data all the way downstream to all your downstream systems. And so let's say you start with a terabyte, but you're actually cutting 40 or 50 or 60% of that data out because one, it might not be useful. Two, it might be low value parts of an individual event or log. And so you can, you could pretty much cut out a lot of this volume and data sets and still derive the same insights that you need. That to us, what we call an optimization summary. So that could be, 30%. We have customers as high as, 85 or 90 or 99%. Again, we don't ever claim that every single customer is going to be able to achieve, 90% or 95%, but it is a reality that some data sets do have a lot of low value data within them. And the final thing is destination and tiers. So one thing that's becoming very popular in the enterprise is this concept of data tiering. And so what is data tiering? Nolan, I think, mentioned it a little bit today with the various different types of intelligent tiers in S3 and the various different types of storage classes. It's not that all those data sets need to be replicated to every single system. So for instance, let's say you had your security team using Splunk, you had your observability team using Datadog, you wanted to use telemetry pipelines. What typically we're seeing in the enterprise is 100% of your data can be stored in S3. It is so efficient to store your data in S3 at scale that most organizations will just say, hey, let's go take a raw copy of all our data and put it in S3. In addition to that, you can take subsets of that data and also push them to other downstream systems that I've mentioned before, all for various different observability and security use cases. So that is a concept of data tiering where you might have a high performant data tier that costs a lot more than a low performant data tier. And so you really need to optimize and understand your strategy for how do I actually get the appropriate data set and the appropriate downstream destinations. Second thing is visibility. So this is a granular view into your telemetry. So again, talking about applications and third-party services, understanding where's that data coming from. If we think about the app services, the logs, metrics, events, traces, individually, what is happening to each individual piece of data? When you start to deploy telemetry pipelines, you get a very, very good granular view into what's happening with all your data. Finally, the architecture and integrations. So we all use lots of downstream systems. I think in the screenshot, we have New Relic, we have Grafana Loki, we have Sumo Logic, we have Prometheus. But you can also use tools like PagerDuty or Slack or Jira or ServiceNow. And so these are all the various different downstream destinations that when you're using pipelines, you have full control and flexibility over how you're going to integrate with those downstream destinations. Finally, the third thing, which is capabilities, right? If you want to capture your data, you want to sample it, you want to test to say, hey, if I were to implement this new rule, what does my downstream data look like? These are all the various different, transformations and different things that you can do with your data to get a very good understanding of what's going to happen to it as it's flowing through your telemetry pipelines. This concept of like in-stream modifications and manipulations. So again, transforms, filters, sample, you can enrich that data with lookup tables. You can mask parts of it if you had sensitive data in there. You could pre-process, pre-aggregate. So sometimes, to take an example, I might just simply want an error rate on a Splunk dashboard, but I don't want to go send my terabytes of data into Splunk in order to get one specific metric. That is a very good example of a pre-aggregation or what we call a log to metric to say, I want to derive this metric out of this log. I want to go send that metric downstream to whether it's, Splunk dashboards or, again, it could be Datadog. It could be, wanting to go dashboard it in Grafana through Prometheus. So, you could do whatever type of setup you want, but this whole concept of being able to shift left and have full control and flexibility over your data sets instead of wait for that data to be indexed downstream and incur all those costs, that is becoming very popular, especially among the enterprise. And then finally, the last thing is AI-enabled routing logic and efficient destinations. We have full-on, obviously we are an AWS Bedrock customer. We have full-on AI-enabled within the telemetry pipelines itself. So you can even ask AI to say, hey, I want to go make a modification to my pipeline. I want to go filter out this specific type of data set. It will actually implement that rule for you without you having to write any type of regex or any type of, a common expression language or any type of logic. And you can just see that rule, you can test that rule, and you can deploy that rule if it's something that is satisfactory to your needs. So looking at case studies, We have a lot of public case studies that we have on the website. You can go there, you can download them. There's a lot of information that's in those case studies that I'm probably not going to go into today about how people are optimizing and how people are reducing costs across their various different observability and security platforms. But again, we are seeing this shift left, which enables that control, flexibility, and cost efficiency. We're seeing people implement telemetry pipelines to allow them to aggregate, transform, enrich, and route data to downstream destinations. We're seeing people use fleet management. So, along with Edge Delta Telemetry Pipelines, you get this really great fleet management. So you don't have to go individually manage each individual agent or each individual mechanism to send this data somewhere else. It's all handled for you through a really, best of both worlds of both SaaS and on-prem in sort of this hybrid deployment. And then the AI capabilities give a huge improvement in uptime and availability. I think it's unreasonable for us to put a standard on engineers to say, you have to come up with logic to solve tomorrow's outage. So it's really great to be able to use machine learning and AI to be able to understand your data in real time and look for these anomalies in real time and be able to really have a huge improvement in uptime and availability with those mechanisms and with that functionality. So what does a typical architecture look like? Well, you have your data sources on the left. So those can be AWS CloudTrail, they could be AWS Lambda, it could be Akamai, it could be your Linux eBPF data sets, it could be AWS EKS Kubernetes. And so these are all the various different data sources that are all emitting various different logs and events and metrics and trace information. In the middle, you have what the telemetry pipelines are doing. So again, they can reduce, they can transform, they can analyze, and ultimately they route that data downstream. Open telemetry is becoming very popular. We are very big supporters of OTel. Everything that we do has full support for the OTel schema and formats. So when you deploy Edge Delta Telemetry Pipelines, you get OTel out of the box. And then finally, where are the various different downstream destinations? So Nolan did a really good job talking about these various different intelligent tiers of S3. You might have some data sets that you want to put into a frequent S3 storage. You might have some S3 data sets you want to put into an archive tier. So this concept and flexibility around data tiering gives you a lot of ability to get the value out of your data while keeping your costs low. And then finally, we integrate with various different platforms downstream, whether it's Datadog or Grafana, as you see on this slide, or other more traditional platforms like Splunk or Elastic as well. And then as well, you get the AI insights right out of the box. Those again can be deployed within pipeline that we saw before to be able to get some various different information more on the machine learning and anomaly detection aspect of it. But also there's some AI capabilities that you can use yourself. And that's a great segue into a typical enterprise architecture diagram. If you look on the top left, that is your configuration. You can think of your configuration as a non-sensitive data set. This isn't even necessarily your data or your sensitive data sets. These are simply, what is a configuration? What is the logic and the rules that my pipeline will use? And then you have the Edge Delta control plane. So again, this can be a SaaS control plane that does all the fleet and data management for you. And then you can use your own AWS account. So one thing that we're seeing in enterprises is they're using their own AWS Bedrock account, and they're basically integrating these telemetry pipelines into AWS Bedrock. They're also using intelligent tiering within AWS S3. So again, there's various different hybrid setups that you can use within your environment. You can go anything from full 100% SaaS to also very, very much a best of both worlds hybrid approach. And so this flexibility and control, that's what you get with being able to shift left and have whole new types of architectures. So I've talked about Bedrock quite a bit. What does it give you? We call this continuous curation and inference. We talked before about it would take 1,500 years for a human to manually read through a terabyte. So we need these systems. We need things like AI that gives us these capabilities. But without the continuous curation and inference, it would blow the bank account. Like you can't actually send terabytes and petabytes of data into any AI or LLM. So really this concept of what are the various different curated data sets that I'm going to go pre-process, pre-curate, and continuously integrate into these AI and LLMs like, again, AWS Bedrock and others. And this is really the power that you get with telemetry pipelines is, again, going back to those concepts of control and flexibility to shift left, do all the various different things that you want with your data, and being able to go to the appropriate downstream destinations, whether, again, that's an AI endpoint, whether that's a system like Datadog, whether that is a storage or archive tier like something like S3 that's super scalable. These are all the flexibility and control that you get with telemetry pipelines. So what is the value for modern observability and security teams? Really, you get to extract these anomaly insights very quickly. So again, if you shift left, you can start some of your logic and start some of your processing and start some of your intelligence right where your data is starting to be created. So that is a huge benefit to a lot of these organizations. The automatic RCA. So we have this concept of on-call AI at Edge Delta. So any type of anomaly, any type of thing that might be some operational, outage or some sort of potential production issue, you get an immediate summary and suggested resolution directly from AI. So this can be really powerful. I think Werner Vogel's in that talk also talked about, hey, AI can predict and recommend, but at the end of the day, the professionals need to decide. We have that exact same view. We're going to give the recommendations directly to the engineers, but at the end of the day, we feel like the engineer is going to be the one that is empowered to make those changes. And then finally, the third thing is cost, right? I think cost is a big, big, big issue in the enterprise. Again, we've all talked about that exponential increase in data volumes. So you have to really think about, if my data volumes are exponentially increasing, if I'm going from megabytes and gigabytes from 10 years ago to terabytes and petabytes today, how can I think through how am I going to architect this system to be able to analyze petabytes of data without spending cajillions of dollars on the back end? So, I think these are the benefits that you're going to be getting with telemetry pipelines, and this is the value that it gives to modern observability and security teams. So with that, I think, we were hoping that there'd be some questions from the audience. And so fire away. Let us know if you have any questions. Otherwise, it's going to be me and Nolan just asking each other a bunch of things back and forth. So I don't know. Maybe, Nolan, if you had something prepared, maybe you can get the crowd started.
Yeah, I saw your slide beforehand, so I was intrigued that you liked the Werner Vogel's story. So again, that was a story where you showed two homes. They're exactly identical, but one of them has the meter in the hidden away in the basement. The other one is visible. And just the act of seeing the meter changes the behavior and energy usage. So translate that to business. Can you talk about some of the behaviors you've seen in customers that got changed just because of better visibility of their applications and IT infrastructure?
Yeah, absolutely. And I think if we go back to that analogy, right? Let's say your energy bill every month was, $1,000, right? Then you're probably going to look at that and say, I need to optimize that. But let's say your energy bill, let's say, I don't know, you have some sort of perfect installation. And let's say your energy bill was more relatively something like $1 a month, right? You might say, okay, well, strictly from a cost savings standpoint, I might not necessarily care about, optimizing for that $1, right? That exact same concept is happening within observability and security. Again, about 10 years ago, you had organizations that had to deal with megabytes and gigabytes of data. If I have 1 gigabyte of data, I don't really necessarily care about my Datadog or my Splunk bill at the end of the day, right? But now we're seeing organizations with the move to microservices, newer architectures, Kubernetes, Lambda functions. There's now terabytes and petabytes. We're talking about thousands or millions of times more data being created than simply 5 or 10 years ago. And so in that analogy, right, now all of a sudden it becomes an issue. Now you have to look at, how do I optimize my data sets? And again, a lot of these platforms, we call it like the first generation observability and security platforms, they were architected in an era when it wasn't a problem. So they don't do a very good job of showing you, hey, what are my individual pieces of data? What are my different logs and metrics? Which indexes, which partitions are they going into? But actually at a granular level, like you can see it at a very high level, but without understanding, it's almost the equivalent of having that meter in the basement where it's out of sight, out of mind. You don't have a very good understanding of each individual different data stream, each individual piece of your data, each part of each individual piece of your data. And so that's where I think Telemetry Pipelines is so exciting, is it gives you that visibility and that insight into all your granular pieces of data. And that gives you the ability to be better than you were yesterday.
Thanks, Ozan. Kind of, for some reason, it reminds me of high school physics when I try to study quantum physics. Like just the act of viewing something sometimes actually just changes behavior, just viewing it. So that's pretty cool.
Absolutely. And I had a question for you, Nolan. I mean, you talked through the, the intelligent tiering and the storage classes in S3. That's such a fascinating concept to me, because I think, S3 is already really effective and inefficient. Really effective in low cost, right?
Mhm.
But even to stretch that even to more value, where you guys have various different options even within S3. Can you talk through that? Why would I use frequent versus infrequent versus archive?
Yeah. So as the name suggests, right? Frequent is for maybe data you access on a daily basis. But you probably like me, right? After a while, a few months on my own laptop, I starts to pile up docs and spreadsheets that, I may have used once or twice a couple months ago, but then I never use again. Fortunately, my laptop hard disk now is getting cheaper and cheaper. But I remember a time when, I don't know if you remember a time even on your cell phones when they first came out, you had to delete old text messages. So obviously, naturally, the natural thing to do is, right, to delete data you don't need. But the reality is companies can't just delete data. Sometimes they just don't know if an auditor will come and ask for the data later. So that's why we offer different tiers of storage. Now, the cool thing about it, I think in the old days before the cloud, storage administrators probably had to manually look at when data was accessed and then copy it to like a tape. And the tape, a guy comes in a truck and puts a tape and takes it to a mountain. So with intelligent tiering, we can automatically monitor the access. Now, the way it works though, from a user perspective, on our GUI, you just make simple rules. Say, with this bucket, if objects haven't been accessed in 30 days or 60 days or 90 days, automatically move it to the other tier. And the cool thing is, if you do happen to want to access the storage, we'll automatically move it from the infrequent access storage to the frequent. Now, you may ask, well, if it's just retrieving storage, what is the real difference? Well, the thing is, for like archival storage, if you actually want, most cases, if you want to retrieve the storage, it could actually take several hours sometimes. So if you really only want to put data that you're unlikely to need, but just in case an auditor comes back a few years later asking for data, you can get it. But then we realize there's also sometimes there's data that they don't think they'll need, but when they actually need it in a few seconds. They need it almost right away. And that's what infrequently accessed storage is. Costs less to store it, but when you do retrieve it, it does cost more money to do each retrieval. So we're always, I mean, a lot of our services just come from directly feedback from customers. And I think this model, it probably was mostly designed with human data in mind, meaning human generated data like spreadsheets and files. I think the bigger challenge, though, is with telemetry data generated from machines. It's hard to know ahead of time whether you're going to use it in 30 days or 60 days and whether you should move it to different tiers. So that's why I think it's really important what you talked about is maybe some of this should be shifted. Some of this pre-processing should be shifted left.
Yeah, yeah. When you were talking, it reminded me of my father when I was a kid. He said, nothing can beat a semi truck full of CDs driving across the country when it comes to bandwidth, right? So, I don't know if that's necessarily true today, but I'm sure a semi truck full of storage drives still can give the internet a run for its money, probably. But I think the concept of the different S3 tiers, it's so powerful because, again, what we are seeing in the enterprise is this concept of data tiering, right? So, data tiering is that aspect of, okay, not all of my high volume data can be stored in every single downstream system. There's just too much data today. So that makes a ton of sense.
Okay.
Looks like
I
we
have one more.
got oh, sorry.
Go ahead, Sarah.
I was just gonna say, it looks like we got a question from somebody, one of our attendees. I didn't mean to cut you off though, but it says, what would you say to someone who says they're already using homegrown pipelines, and why would we need a solution for it?
Well, I think that's a great question. So, I mean, so my past, before Edge Delta, I was at a company called Sumo Logic that did, full on, multi-tenant cloud-based observability. Primarily it was starting with logs, but in later years they added, metrics and sort of, APM and tracing support as well. And so even in the early days, we had customers that 10 plus years ago were saying, hey, I'm just gonna kind of use open source and roll my own Elastic and I want to go manage my own elk stack, which is, Elastic, Logstash, and Kibana. And even today, people are still doing that. So I think, it really depends on the setup of your team. If you're the type of team that's saying, hey, we're going to build everything in-house, that is a perfectly fine and perfectly acceptable way to do it. If you're a team that says, hey, you know what? I do want to use a SaaS service. I do want to use kind of the best-in-class SaaS tools. Then I think, take a look at Edge Delta from a telemetry pipeline standpoint. And there's a lot of features and functionality that we have that you might not have already built in-house. And then again, there's also, a healthy balance. Sometimes you see teams, just like we see teams that are using, some teams are using Datadog and some teams are using Grafana, or, security teams are using Splunk and the observability teams are using, some other tool, right? So, I think there's always this approach of various different use cases, especially in the enterprise where you have so many different teams. But, if you've built your own telemetry pipelines, if you have no issues with them, then that's a perfectly fine way to go. If you have built those and you have a lot of management overhead, you're having challenges manage them, you're having challenges with scalability, then again, you can look at more of an enterprise class solution as well. But again, it's going to come down to your different team and your different, capabilities and expertise within your team.
Awesome. We've got a couple more questions. One is, are there specific requirements or dependencies for integrating with S3?
Integrating, might want to know a little more detail what you're trying to integrate, but basically S3, like all services on AWS, it's pretty much API driven. In most cases, it's an HTTP call, or we have an SDK that makes it easy just to access to, very simple operations, put files there, get files. So I don't know if that answers your question, but it's API driven, and it's designed really to integrate with almost any kind of application that's has to write data. Now, the important thing is, reminder is S3 is object store, so it's not a file system. So it doesn't it doesn't have have the offer like concurrency where you can have multiple people collaborating. So there's a lot of partners we have that can add those additional features you want. But basically, yeah, S3 is to access it or to integrate it with any other applications. It uses an API driven approach. And I don't know, Ozan, if you want to comment how Edge Delta in particular reason writes to S3.
Yeah, I mean, so, there's a few different ways. One thing is, obviously, we're a large S3 customers. So, for our customers that are saying, hey, I actually do want to use end-to-end Edge Delta. I want to use your guys's, logging and metrics and tracing capabilities and everything else. So I want to use telemetry pipelines. I also want to use your observability. You can absolutely use our own kind of integrated S3 that we're using within our service. The other thing that you can do, and what we've seen with a lot of our large enterprise customers, is you deploy telemetry pipelines. You can send some pieces of data to a downstream observability tool, but also S3 is going to be orders of magnitude less expensive than an observability or security tool per unit cost of data. So we're seeing customers, again, implement that data tiering where they're saying, hey, I want to go send X data set into my security SIEM. I want to send Y data set into my observability tool. And then I want to send X plus Y plus Z and Q1 and Q2 and all these other data sets directly into S3. Nolan, to your point, you might need that for forensic security investigations later on. You might need that for audit, for compliance. You might just have, massive BI use cases where you're saying, hey, I want to run a SQL query and use Athena and get some sort of insight or derive some sort of information about my data later on, right? So S3 is, I would say, best-in-class solution for thinking through, hey, I want to go make sure I have a raw copy of all my data for, safe and simple and secure storage, right? So, that's what I want. And I don't know how I'm going to use that data later. I know I have some various different things that I need to use it for, but there might pop up a use case tomorrow that I didn't think about. And I have a really easy access to all that data. That's where the benefit of being able to use your own S3 buckets and say, hey, I mean, and this concept has existed for a long time, right? For the last 10 years, we always saw observability and security teams saying, hey, I want my data sets here, here, and here. And by the way, I also want a raw copy of all my data in my own S3 bucket so I can have full control and flexibility of that data later on. That is something that, I would almost argue every single enterprise should be doing. Again, if you're creating, petabytes and petabytes and petabytes of data every single day, and you're at that scale of, some of our customers do, upwards of 80 to 100 petabytes of data they create every single day. Maybe if you're creating 100 petabytes of data every day, maybe you don't store every single petabyte in S3. But for the most part, in my mind, there's no better place to be able to have something that's reliable, consistent, scalable, especially when you don't know how your team's going to be using that data tomorrow.
Thanks, Ozan. One more comment about integrating with S3 is, I think you sort of touched on it, is security. Security is job zero at AWS. So with S3, we make sure that by default, nobody can really access it unless you give it people explicit, or roles or other services explicit permission. We also remind you that you can also turn on encryption to make sure your data is secure. So that's obviously a very huge issue. I mean, data security is always a huge issue, but I think with the increasingly large volumes of data, S3 is designed so not only could it be high performant, low cost, but also most importantly, very secure.
Awesome. We have another question for you, Ozan. Can you talk more about what you mean by shifting left? You mentioned aggregation of metrics during the pipeline instead of waiting until it hits storage, but what are some other use cases examples?
Yeah. So this is great. So, there was this kind of these terminology that we were using a long time ago, right? Store and explore, or centralize and analyze. And, if you think about going back to the analogy of the energy use in the homes again, right? If your energy bill is $1, you might just say, hey, I want to make sure that my family and everyone is comfortable and warm and healthy. If it's, $10,000 every month, you might say, how do I optimize this? And, back in the day when megabytes and gigabytes were being created, you didn't really have to be thoughtful about it. And frankly, there are benefits to sending every single piece of your data downstream, right? But the reality in today is that, a lot of data is being created, and you have to be a lot more thoughtful and proactive. So when we talk about shifting left, all that really means is, how do we go more upstream? And how do we have some more logic and intelligence and all the various different things, not simply in my backend data store, not simply in my observability or my security tool, but also some logic to say, okay, at the source, let's take Kubernetes, for example. I have my service running in Kubernetes and EKS. That's creating a lot of data. Should I have some more sophisticated logic running within my EKS to decide what are my various different data sets that should be going downstream? Where should they be going? So that's kind of the concept. If we think about the architecture diagram, and we think about the source of your data being created on the left, and on the right downstream is all the data that's being indexed, in various different indexes or partitions or storage tiers. Again, the traditional older approach was, don't even think about it, just send all your data downstream. And again, that worked at relatively lower volume data sets. But now we're really seeing it become very popular to shift left and start to do a lot more upstream. And, again, concrete example, I use kind of a pre-processing log-to-metric example, but it could also just be as simple as, hey, I have my data set downstream, and I actually want to filter out or cut out pieces of that data that I don't need. And I know if I cut it out upstream, I don't have to incur all these costs downstream. I don't have to take my, open telemetry agent and then go have that compress and encrypt that data, send it up into my, my Kafka stream. And then in Kafka, I incur more costs. And then I have to go take that and ingest that into, Datadog. And then I incur even more costs ingesting that into Datadog. Then I got to go index that in Datadog and incur even more costs, right? So every single time you're working with this data, you can almost think of it as, IO and read writes. And every single time it takes a lot of CPU and memory and frankly, just a lot of cost to perform that movement of that data. So if I know that there's some piece of data that I'm not going to get value out of, why not cut it out upstream before I've already incurred all those costs? That is really the concept of shifting left. And again, it can be as simple as filtering or sampling data, and it can be a lot more sophisticated than that as well.
Awesome. We have what feels like kind of a follow-up question to the first question that was asked about using homegrown pipelines. What are the advantages of building versus buying? And can anyone build the same telemetry pipeline agents?
Yeah, that's a great question. So, open telemetry is open source. And so you can absolutely, if you have the capabilities and the expertise within your teams, like let's take my co-founder, for instance, right? Fatih, phenomenal engineer. Fatih can do pretty much, I mean, he's so impressive. He's phenomenal. Fatih came from Twitter and a lot of the companies that are, I would say, in the, let's say, top 5% of the most sophisticated, the most advanced, the most fast-moving companies, companies that maybe were a startup a few years ago, and all of a sudden they're a huge company because they're moving so quick. A lot of those companies typically will build a lot of this stuff in-house. Again, they have the expertise for it. They have the engineers. Like some of them might not even use the cloud at all, right? So I think it kind of comes down to what is the core capability of your team? Some teams, like I think Facebook is very famous, or Meta, I should say now. Meta is very famous for now, they have their own data centers. They have their own co-locations. I think I heard somewhere some statistic that Meta is actually the largest concrete buyer in the world. They're literally buying as much concrete as they can to go build their own individual data centers. But the reality is that 99% of the market is just going to use AWS. They're just going to use a cloud service, just like you're just going to use a SaaS service, such as Edge Delta or such as Datadog or such as, potentially Splunk. So again, there are those open source tool sets for you to be able to build your own mechanisms, and whether it's observability or security or telemetry pipelines, that kind of comes down to you. I would say probably that Edge Delta has a lot of things that OpenTelemetry project doesn't have, just like Splunk has a lot of things that Elastic doesn't have. So I think, again, you might be able to say potato, potato, tomato, tomato, or you might just be able to say, hey, look, we recognize that we don't have the time or the effort or the expertise within our individual enterprise team to be able to go build this stuff from scratch. And frankly, we don't want to go reinvent the wheel. Like this t-shirt, I didn't knit this t-shirt myself. I went and bought this t-shirt. Like I could probably knit it if I spent enough time knitting. But, reality is I'm going to go focus on my core competency. And that's what we're seeing with enterprise teams. They're saying, look, we are not a telemetry pipeline company. We are not going to go build a telemetry pipeline technology from scratch. Again, we could use open source. There's some open source projects out there. As I mentioned, OpenTelemetry is one that we're very supportive of. Or I'm going to take something off the shelf as a SaaS service and go use that, such as Edge Delta.
Yeah, this makes me think of what Andy Jassy, our CEO, says. Well, at least for AWS, we help our customers. We take care of the undifferentiated heavy lifting. So, yeah, there's smart people everywhere.
Exactly. I mean, look, I spent a lot of time in the early days of the cloud as a developer, in the cloud. And, I was in those data centers, like manually plugging in the, Ethernet and InfiniBand cables and manually moving servers. And like, that's all the stuff that if I'm going to build a startup or even a large business tomorrow, I don't want to go do all those things. That's what's handled when I just say, I'm just going to use EC2 or I'm just going to use EKS. Like, I don't want to go deal with, making sure that I don't have my coffee in my hand when I'm in a data center because I don't want to spill it on all the servers, right? Like, that's the stuff that, it's a hard business dealing with a lot of this complexity. It's already hard enough. I want someone else to go take care of the things that I don't want to be my core competency so I can focus on what matters.
Like we have another question. Sec. So, okay. How do you make sure the filtering on the left will align with the analytics on the right? Like maintaining the stability of the meaningfulness of the aggregation.
Yeah, so this is probably a very prime example. Actually, great question. Why you actually probably want to use something like Edge Delta. So what Edge Delta allows you to do is on the left where your data is being created, that is typically where the logic starts. Let's say you implemented some really basic rule, right? Let's say, for instance, you said, hey, I have these IP addresses in my information and I want to simply mask that out. This is a very simple example. What you can do is you can put in a mask filter in the logic of the pipeline, and you can actually go look at your data before and after and say, whether it's my regular expression, whether I want to use common expression language CEL, how is my data actually being changed? And you can say, oh, I see it now. I'm comparing the log message before that has the IP address in there to the log message afterwards, which is masked with a bunch of characters, right? Or hashed. So you can do that comparison. You can say, okay, now I understand how my data is being changed. And we have a really great, easy view where you can actually see that all. And I think I showed it in some of my slides earlier, where you have a really easy view where you can actually see how that's changing. And by doing this, you can actually compare to say on the left where my data is being created compared to on the right where my data eventually ends up. I don't want my sensitive data sets to make it into my downstream systems, but I also want to make sure that the quality of my data downstream is a good quality data. I don't want someone to go mess with my data and it then goes downstream and doesn't hit downstream data sets in, appropriate or the right format, right? And so, this is the benefit of using something like Edge Delta, where you get a very easy understanding visually of how my data is being changed. The other thing that we have is we have this concept of, compound nodes where you could, it fully supports RBAC. So for instance, you could say, hey, I want to give a team access to only this specific part of my pipeline to only be able to modify a data set that they should have ownership of. But I also don't want them mucking around with all the other data streams. And so this is fully supported where you can have subsets of logic within your telemetry pipelines. And you can ensure that, for instance, someone isn't going to mess with data set and make sure that, the data sets on the right downstream that are being indexed in more maybe performant and more expensive downstream systems, that they're going to be there in the right format, that you're going to ensure that it's always there. That is really the big benefit to pipelines. Again, when we talk about, being able to, at a very granular level, understand your data, before we weren't able to do this. Before we were just saying, hey, just send it all in raw format, and then we'll try to deal with it within a downstream system. And again, that works at, megabytes and gigabytes. For even some large enterprises that are very profitable, they can make that work at terabytes. But, again, that completely falls apart when you get into the hundreds of terabytes or petabytes where you can't necessarily send everything downstream. Hopefully that answers your question.
Awesome. All right. We're almost at the top of the hour, so I want to be respectful of everybody's time. We've got one more question, and probably all we have time for, but so this one is, we are revisiting different observability options due to costs. And I heard anomaly detection in Edge Delta mentioned in the conversation. Could you talk a little bit about how that works?
Yeah, great question. So, anomaly detection as a concept has existed in observability and security for, I don't know, at least 10 plus years. So, let's take the right approach first. So, like literally the left-right approach. So the rightmost approach is, hey, let's go ahead and send all this data into a downstream system. Let's have some logic and some queries chugging through all that data. Usually it happens in a batched or periodic format. So you might say, hey, I have this specific query. I want to run this query every 15 minutes on this data set. If you want to be more real time, some systems allow you to say, hey, I want to go real time or run it, let's say once per minute, and look for these various different conditions. So that is the more traditional rightmost approach that has existed in the market for a long time. What Edge Delta is doing is it's saying, actually, we think the whole end-to-end process should be more intelligent. And that goes all the way down to the left side of it, which is your source of data, which is where your data is being created. So let's say, again, I'm using AWS EKS. My application's running in Kubernetes, and having all my data being created in Kubernetes. Could there be some sort of anomaly detection or statistical deviations in my Kubernetes environment that I care about, that I don't want to wait for that data to be indexed downstream before I go and run some of that logic? So that's where you can be a lot more proactive with your anomaly detection, to be a lot smarter, a lot more intelligent. We talk about this concept of intelligence end to end, and that's probably a really good example of that, where before you had these really dumb, simple agents that were simply saying, hey, all I'm going to do is compress and encrypt data and send it downstream. And now we're seeing, modern enterprises are moving to a lot more proactive approach and saying, hey, I want the whole end-to-end process to be intelligent. So again, that could be something like error rates going up. It could also be something like, hey, why are we getting 10 times more data than we were before? Or, hey, why did this specific data feed stop, right? So those are all the various different types of anomalies that you care about within your enterprise systems.
Awesome.
I think I
Well,
finished that right on time, right on the last minute. So,
very impressive.
Good job.
Did it.
all right. Well, I want to thank everyone. Again, please reach out to us if you have any other questions. I have the website up here. The other thing you can do, and this is on our website anyways, but you can go to play.edgedelta.com. Play.edgedelta.com will just give you a demo environment that you can just start playing around with, start clicking around and seeing the concept of pipelines. In that environment, if you go to the pipelines tab and you go start clicking and looking at editing pipelines, you can even go through and edit your pipelines. So it's a really great demo environment. You don't have to, deal with trying to set it all up yourself. And, again, I want to thank AWS as well. We are very happy S3 customers. We're very happy Bedrock customers. We're using a lot of storage and AI directly within our products. So Nolan, thank you for always supporting us. And thank you for this chat today.
And thank you. I'll put one more plug. If you want to use Edge Delta on AWS, check them out on our AWS marketplace. Type Edge Delta.
Okay. Thank you, everyone.
Thanks so much, everyone.
Thank you.